Welcome to the Canada Science and Technology Museum in Ottawa, Ontario, in our artifact storage facility. Hi, my name is Michel. I'm an educator here at the museum. Why have telescopes changed, and what advantages do the various types have to offer? To answer these questions, think of your eyes as a pair of small telescopes.
You can see very well during the day, but it's difficult to see things at night. That's because our eyes only work well when there is enough light.
The same is true for optical telescopes. They require sufficient light from a star in order to display that star's image. Bigger telescope mirrors and lenses allow telescopes to gather more light. This is why telescopes have grown in size since they were first invented. Now think of your ears, which gather more information about your immediate environment than your eyes do, in the light or in the dark. In the 1930s, an engineer by the name of Karl Jansky discovered that the sun emits radio waves, not just visible and infrared light. He built the very first device to listen to the sun. We call that a radio telescope, such as the example we have here.
Radio telescopes collect radio waves from far-off stars and focus them onto a detector. With the help of these instruments, we began to build a completely different view of the universe. Astronomers discovered all kinds of new, exciting objects such as radio stars, radio galaxies, quasi-stellar objects called quasars, and black holes. All of these celestial objects were invisible or appeared very ordinary when examined with optical telescopes. Here, we are looking at a model of the National Research Council's radio telescope in Algonquin Park. This telescope played an important part in one of the most significant achievements carried out with radio telescopes. In 1968, astronomers combined radio signals received at two large radio telescopes. This telescope, located in Ontario's Algonquin Provincial Park, and the Dominion Astrophysical Radio Observatory, located thousands of miles away in Penticton, British Columbia. Together, these two telescopes formed a new instrument called a long baseline interferometer.
By combining these radio telescope signals, astronomers could examine celestial objects in rich detail 1,000 times greater than optical telescopes could, until, of course, the launch of the Hubble Space Telescope in the 1990s.
The long baseline interferometer is a proud Canadian achievement. The team involved in this research was awarded 2 Rumford Medals, gold and silver respectively, by the American Academy of Arts and Sciences for this remarkable achievement. To learn more about astronomy and telescopes, visit the Canada Science and Technology Museum.